Let's see how to use trigonometric ratios to find missing sides. And before we start, let's revise what trigonometric ratios are. So we have sine, cosine, and tangent. And these ratios help us to work with right triangles. So let's recall, if we have two angles in a triangle, in any triangle, we can always find the third one. If we have a right triangle and no two sides, we can use Pythagorean theorem to find the remaining third side. But trigonometric ratios basically connect angles with sides. So if we have a right triangle and one non-right angle and one side, we can find the remaining other two sides. So that's the magic about trigonometric ratios. So we didn't have this tool before, and let's learn how to use it. So we have a triangle ABC, and we're going to call the opposite sides with lowercase ABC. So when we talk about trigonometric ratios, we refer to angles. So we have to say sine of an angle or cosine of an angle. So we have to choose one of the angles. Usually we talk about non-right angles. So let's say sine of A, and let's find cosine of A and tangent A. Now, to memorize the definitions, we use this mnemonic. So, ka, toa. It's so silly that actually it sticks in your mind. It doesn't make any sense, to be honest. It's just this gives us the order that we put the ratios in our equations. So stands for sine. And again, why we call it ratios? Because we're going to divide opposite leg over hypotenuse. So for example, sine of A will be opposite leg, which is side A, over hypotenuse C. Now, for cosine, we go as adjacent leg over hypotenuse. So for angle A, adjacent leg is B, hypotenuse is C. Hypotenuse is also adjacent, but when we talk about adjacent, we mean the leg, not the hypotenuse. So hypotenuse has its own letter H. And tangent is opposite leg over adjacent leg. So opposite leg is A, and adjacent leg is B. Now, knowing this, let's actually go ahead and try some examples here. So let's say we have a triangle. We have a right triangle. And let's say this angle is 42 degrees. This side or this leg is X, and the hypotenuse is 22. So how to find the missing leg? So it all starts with what is given. So let me highlight. So we always start with the angle, always start with the angle. So in terms of this angle, what is given? We have the opposite leg and we have the hypotenuse. Now let's go back. I'm going to write here, so, ka, toa. So if we have opposite leg and hypotenuse, the only ratio we can use is sine, because for cosine and tangent, we don't have the adjacent leg, right? So we're going to we start with the definition. We start with sine. So first we decided we're going to use the sine. We're going to put the angle measure right next to sine. So sine, cosine, and tangent always comes with the angle. So sine of 42, according to definition, it's a ratio of opposite leg over hypotenuse. So from here, we can multiply each side by 22. Let me just write it here. So we multiply each side by 22. And look what we have now. X equals 2. Sine of 42 times 22. Now, when you put this on your calculator will open parentheses here. If you don't close it, it's going to multiply 42 with 22 and then take a sign. So don't forget to close the parentheses and then multiply by 22. So by doing that, you should get that your leg is about 14.7. We can do a quick check. So your leg must be smaller than hypotenuse, because hypotenuse is always the longest side of a right triangle, and it is less than 22. So it does make some sense. So let's look at second triangle. I'm going to use exactly the same numbers, but now I'm going to put 22 and x. I'm going to switch the location and show you what changes if we have a different location for x and 22. So again, we always start with the angle. Okay. So we always start with the angle. So for this angle, what do we have? We have, again, opposite leg, and we have the hypotenuse. Okay, so that means we're going to use the sine. Let's write the sine. Hold on. Where's my pen? So let's write sine of 42 equals 2. Now, according to definition, we have to write the ratio opposite leg to hypotenuse. Look at the difference. Now our x is in the denominator. Now, I can rewrite it as a proportion, right? And use cross products. X times sine of 42 is equals to 22 times 1, right? Which is 22. To find x, we're going to divide each side by sine of 42, and that's what we should put in the calculator. So here we go. Now, your answer should be about, so we round up here, or round down according to what we get. I got 32 and 9/10. And let's do a quick check. X here is a hypotenuse. It has to be longer than the leg. And yes, it is. So it does make sense for our numbers. So again, if you have x in the denominator, so if we need to solve it for x and x in the denominator, look, according to rules of proportion, you can switch the x and sine of 42 around. X will go up, sine of 42 will go down to the denominator. Or let me just write it this way, C2 x, let's say. To find the x, we're going to multiply these two and then divide by whatever is across x, right? So we multiply 22 and 1 and divide it by sine of 42. So that's a shortcut I like to use. Okay, let's move on to another two examples. And again, we have right triangles. We cannot use trigonometric ratios for non-right triangles. We're going to have two rules that work with non-right triangles. But for now, sine, cosine, and tangent are going to be applied in right triangles. And let's say I have here angle 50 degrees. And let's say this is x, and this is 40. And for next one, let's say I'm going to change the location of an angle. So this is 50. This will be x, and this will be 40. So let's see what we get in each example. So I'm going to write here again, so ka toa, okay? And we always start with an angle. So we have this angle. For this angle, what is given? This is the adjacent leg. This is the hypotenuse. So adjacent leg and hypotenuse, we can see it only in cosine, right? For sine and tangent, we don't have the opposite leg. So we have to use cosine of the angle. So we always use angle inside sine, cosine, and tangent. And again, we go by definition, adjacent leg over hypotenuse. So again, you can use it as a proportion. So x times 1 equals to cosine times 40. So which is, I'm going to write it this way, times cosine of 50. So here you should get about 25 and 7/10. Let's do a quick check. It should be less than hypotenuse. Yes, it's less than 40. Now let's look at the second picture. Again, we always start with an angle. For this angle, what do we have given? So in terms of this angle, this is the adjacent leg, and this is the hypotenuse. So again, go back to SOHCAHTOA, we have to use cosine. Cosine of 50 equals 2. It's a ratio of adjacent leg over hypotenuse. Again, you can rewrite it as a proportion. And for this one, I'm going to use a shortcut. So I'm going to multiply 40 and 1 and then divide by cosine of 50. If you don't see this way easy to deal with, you can always use cross products and simplify from there. So x equals to 40 divided by cosine of 50. And you should get about 62 and 2/10. And again, let's do a quick check. It should be longer than your leg. And yes, it is. Okay, 2 more questions. And again, I'm going to use the same numbers. But I'm going to, so here, I'm going to use this angle 39. And let's say this angle is 39 degrees. And let's say this is 15 and this is x. And here I'm going to take this as x and this is 15. So we still use sine, cosine. Hold on. So contour. I'm going to keep it here. And let's always start with an angle. So it's all around the angle. For this angle, what is given? We have the opposite leg and adjacent leg. Opposite and adjacent leg. We don't have the hypotenuse, so we have to use tangent. So that's how we decide which ratio going to work for each problem. So tangent of 39 equals to opposite leg over adjacent leg. So again, multiply each side by 15. That would be 15 multiplied by tangent of 39. Use your calculator, should be around 12.1. Now, how can we check this answer if it makes sense? So how much is this angle? So we have 90 together, right? And we have to take 90 and subtract 39. And that should be 51, right? If you remember, across the bigger angle, the wider angle, we have a longer side. So across 51, we have 15. Across 39 should be something smaller than 15. And yes, it does make sense. And let's look at one more question. So for this question, this is the angle we're going to work around. This is the adjacent leg. Again, this is opposite leg. We have to use tangent because we don't have hypotenuse for sine or cosine. So let's write tangent of 39. Now use the formula exactly how it is. So use the definition. Adjacent leg over, opposite leg, sorry, over adjacent leg. So you can complete it to a proportion. And here, I'm going to multiply 15 times 1 and then divide by tangent of 39. Let me write it down. So 15 divided by tangent of 39. So should be around 18.5. Okay, and again, this angle right here is 51. It's wider than 39, and that means the x should be greater than 15. And yes, it is. Now let's try one more question, and I'll try to do like one word problem. So in San Francisco, Filbert Street has an angle of 17.5 degrees. So let's assume that you drive 500 feet. What will be the height from this point? So if we take this as a horizon, what will be the height from the horizon? So when you work on word problems, so the vertical distance, the height, it always refers to this vertical leg. The horizontal distance will be this leg or distance to the base of something, right? So that's always talk about this bottom leg. And again, we always start from the angle. For this angle, in terms of this angle, what is given? This is the opposite leg, and this is a hypotenuse. Remember what we need to use? We have to use sine. So sine of 17.5 equals to opposite leg over hypotenuse. And here we're going to multiply each side by 500. So sine of, your calculator will open parentheses. Don't forget to close parentheses and then multiply by 500. Okay, so your height will be around 150 feet above the horizontal line. Does it make sense? Yes, it's smaller than the hypotenuse, and it does make sense. So in the next video, I will talk how to find missing angles using trigonometric ratios.